Okay, so let's set this triangle up. It tells me A is 10. Well, opposite A has to be alpha. I don't know alpha. You don't have one?
No, I have one.
Oh.
I don't remember. I don't know if anybody told them that their commission told us that they're bringing back $100 from last for a year.
Bringing back what?
The $100 from last class.
Is that for sure now?
Yeah.
She said it was through this year and next year.
Okay. I mean, I knew that they had mentioned it, but I haven't heard anything else about it. Did I tell you guys that? Okay. Maybe it was my other
You told us that they
pre-cal class I told.
might.
That I had heard rumors but I think it's just for the students. So I'm proud for y'all, but I don't really care, just to be honest. I cared a lot more when I also got $100 for every passing score. Is everybody okay with the setup? So you set up the exact same way you do a law of signs problem. Now I start with, can I use the law of signs? Because if I can, I want to. It's a lot easier. Do I know an angle and the side opposite? I don't. So this is where I can't use the law of signs. It's out. Again, Northeast teaches it as this is a side angle side problem. You know, two sides and the angle between. Okay? So if you want to remember that way, you can. I just know I don't have an angle and a side opposite, so I can't do the law of sines. So whenever you do the law of cosines, we want to first find the missing side. Use the law of cosines. So we're going to find side B. So I don't guess I've written this down yet. Let's see if I can remember it from memory. Law of cosines is a squared equals b squared plus c squared minus 2bc cosine alpha. Alpha. Is that correct? Was it written on the page before? They wrote it as ac squared equals a squared plus b squared minus 2ab. The same thing. Oh yeah, they're right there. And so again, there are three versions. It just all depends on which side you know. So if I'm looking for A, then I'm going to use angle A. And these will be the other two sides. If I'm looking for B, this is angle B with the other two sides. And it's always this side and this angle have to match. So I guess technically, if we want to get technical, with this problem, because I know angle beta, I'm looking for b squared. So it would be b squared equals a squared plus c squared minus 2ac cosine beta. That looks very confusing, right? With the c and then cosine. So I'm going to put that in brackets, just so you can see the difference of sides versus then cosine. But you see how these are the same formula, it's just all about which side you're given or looking for and which angle you might be given or looking for. Alright, so let's plug into the formula. So I'll use the bottom one here. What's my B value? I don't know, that's what I'm looking for. What's my A value? 10. What's my C value? 12. What's my A value? 10. What's my C value? 12. Cosine of what's beta? 30. And now is B isolated?
Yes.
Well, it's squared. So how can I get rid of the squared? So what I'm putting in my calculator is this. The square root of. And I would just type all that in. Unless you want me to try to do it in my head.
Yeah, do it.
100 and 144 is, that's 244. 244, this is 120, 240. 244, 240. Cosine of 30 is radical 3 over 2. So it would be minus 120. Radical 3. Yeah, it's not going to be pretty. Here's what it's going to be. The square root of 244 minus 120 radical 3. So I've got a radical and a radical. I can't do it. I was hoping because it was a good angle that I would do an easy one. What'd y'all get? 6.01. So we'll just go with 6. All right, 6.0. Did everybody get that? 6.0. Anybody need help with that part? Now, I've got 2 missing angles. Do you know an angle in the side opposite?
Wait, do you not take the square root of 6?
No. I took the square root of all of this. Why would I square root again? I already did the square root. That's what the orange is. It was not, there is no square root originally. So I did take the square root. Very good. It technically does. Can we have negative side links? So it's always the positive. Unless you're going to go into a physics class where direction could be positive or negative, so we would have a negative. But for this, we don't. We're not in physics, luckily. But you see how I now have an angle in the side opposite. All right, so now I'm going to do the law of sines. Here's what's important to make sure that we don't have to do the cases. We'll do the law of cosine. We have to now use the law of sines to find the next smallest angle. So that's important. So we would do sine of 30 over 6 equals, what's my next smallest angle? Alpha. Because 10 is the next smallest side. So we know opposite it will be the next smallest angle. So we would go sine of alpha over 10. And now it's like what you did yesterday. This would be 10 sine 30, which is a half. Let me don't do that. That's just going to confuse people. 10 sine 30 equals 6 sine alpha. Divide by 6, divide by 6. Which means sine alpha equals 10 times sine of 30, which is a half. I'm still going to leave it. Over 6. Then we're going to take the inverse sine of both sides. So alpha equals 56.44. So we're going to go 56.4. All right, here's why we did this. Because we took the law of sines, we used the law of sines because we took an inverse sine. What we learned last lesson was we have to account for what this could be in the second quadrant. So what would 56.4 be in the second quadrant? This is 56.4. That would mean I'd have to rotate 1, 20. You guys have to write this down. I just want you to listen to me for a second. 123.6. So could 123.6 be an angle in this triangle? By looking at the sum of the angles, sure. But because I set up the triangle the way I did, it can't be. because this is the second longest side. Which means if this is an obtuse angle, this would also have to be an obtuse angle. Because this has to be the biggest angle. Right? So it can't happen. So that's why they want us to find the second smallest angle, or the next smallest angle. Because we can then just say there's no way it can be in the second quadrant. I don't have to worry about that second case. Because it will always, it can never be obtuse. Because there's only one angle that can be obtuse. And it would be the biggest. Does that make decent sense? Maybe. So that's 56.4. Now I know two angles. Can I find the third angle? Yeah, the 180 minus. So that's 186. This would be 93.4. So here we go. Starting by finding the largest angle. Which of these is the largest angle? Yeah, gamma. So that means if this is my angle, this has to be the isolated side. So I'm going to get 10 squared equals 5 squared plus 7 squared minus 2 times 5 times 7 times cosine of gamma. Now, there's two ways you can work this depending on how comfortable you are. We can turn all of these into just single numbers, if that makes you feel better. Or you could just go ahead and start doing the algebra now to get the gamma by itself. I will probably put real numbers because I just think it'll make the majority of our class feel better. And I care about your feelings. I didn't say that. I didn't say I didn't think that, but I didn't say it. That's what. No, I'm just kidding. No, it would probably freak people out the first time if you see it the other way. That's a 7. Sorry, I'm doing math and not talking. Is it okay with what I've done? 5 squared is 25. 7 squared is 49. 2 times 5 times 7 is 70. And then I combine 25 plus 49 is 74. So now it's algebra. You would subtract 74, which is 26, equals negative 70 cosine of gamma. And then we would divide by negative 70. So I would get cosine of gamma equals 26 over negative 70. I don't really care what that is. But now to find gamma, I have to take an inverse cosine of both sides. And because my ratio is negative, I know I'm going to get one in the second quadrant. Which means it is going to be an obtuse angle.
Wait, was the cosine gamma still negative over there?
No. I divided by negative.
Yeah.
Negative divided by negative is positive. This is inverse. You know what this?
No, but. Oh, okay. You kept. Okay, I didn't see where you kept that negative. I thought you just switched it.
No, the negative over here.
Yeah, I didn't
26 over negative 70, I just put it out
Yeah, I didn't see
in front. What do we get for gamma? 111.8. Everybody on board with that? Now, do I have an angle in the side opposite? So now I can use the law of sines. It says that we can technically find any angle we want to next. I'm going to go ahead and find the smallest one next, just so we stay in that habit of finding the smallest available angle. So I'm going to be looking for alpha. So run out of space here. This would be sine of alpha over 5 equals sine of 111.8 over 10. Cross multiply 5 times sine of 111.8 equals 10 sine alpha. Divide by 10. Take an inverse sine. So I get alpha equals the inverse sine of 5 sine 111.8 over 10. 27.7.
I feel like we used this.
You have?
When?
Which part? This?
Yeah.
Yesterday
No, like,
in geometry. Maybe you did in algebra 2. Some say no, some say yes, so we're all over the place with that. But
We did it like 2 weeks
Very
ago.
good. Yeah. Yes, we did.
and this class? Oh, I can do
so here's 27.7. Now I know 2 angles. Can I find the third angle?
that. Yes, you can do
180 minus minus
180.
138. So that would be 40 point, yeah, 40.5. I was thinking that's 20. I don't know what I was
Is that true? The minus 180.
doing. Go with this. So we start by finding the semi-perimeter. So in Heron's formula, you'll see that you use S and S and S and S. This S represents the semi-perimeter.
Oh, I love that.
Well, you guys know what a semicircle is?
Yeah.
What is it? So guess what the semi-perimeter is? Half the perimeter. So how do you find the perimeter of a triangle? You add the 3 sides. If you want the semi-perimeter, it's half of that.
Oh, so
Divide by 2.
half.
So this is the semi-perimeter formula. And so anytime you're going to use Heron's formula, you have to know the semi-perimeter.
Semicircle.
And you have to know all 3 sides. So this is a way, before we found the area when we had 2 sides and the angle between. That's what we did yesterday. What was it called? I don't remember the name of it. What's his name's formula? Y'all know what's his name. That doesn't matter. But do you remember at the end of class yesterday, or beginning of class yesterday, 2 sides and the angle between, and we did 1/2 times the 2 sides times sine of the angle between.
Side angle, side.
Again, if you want, this is why I don't like doing the side angle sides, because not really, but sure, we'll just say yes. But yes, you did need side angle side, but it's not what I would, anyways. Don't worry, Cody, just do this problem.
Yeah. I don't know.
So here, we want to find the area of this triangle using Heron's formula. So we know the 3 sides. Well, what's the only thing I'm missing to use this formula? I need the semi-perimeter. So S equals 29.7 plus 42.3 plus 38.4. I appreciate that. Division's not real anyway, so. That's correct. Thank you. Y'all have learned something. Look at this. Everybody good with this? Now we're just plugging in. So the area is equal to the square root of S times S minus A times S minus B oh my gosh, times S minus C. And what'd you get? Oh, y'all ain't done it yet. Okay.
This is just so smooth.
Oh, yeah, cut that off.
What is this?
One thing I just want to talk about here because I think it's cool. Because we're finding area has to be in square feet, right? Square feet. Thanks, Colin. Yeah, we got that yesterday. Yeah, that's nice. So this is a measure of feet, right? So this is in feet, and it's getting multiplied by this, which is in feet, and this is in feet, and this is in feet. So it's actually in feet to the fourth power.
What is feet times feet?
Then I'm square rooting that. The square root of feet to the fourth is feet to the second, which gets me back to square feet. All right, let's look at this. Chicago City developer wants to construct a building consisting of artist lots on a triangular lot bordered by Rush Street, Wabash Avenue, and Pearson Street.
This is the area.
Wabash. You gotta love Wabash. Wabash.
North.
Y'all know the old country song? The Wabash Cannonball? You know that song? Do you really?
I've heard that in a song.
Yes, it's a train. That's the name of a train. It's the Wabash Cannonball. But there is a song like 1920s or 30s. What song? What do you know what song?
What about Yo
Is it called
Salty
the
Dog?
Wabash Cannonball?
That's the name of the. We'll listen to it in a second.
What
This
about
is our
Yo
last
Salty Dog?
problem. We'll listen to it. Because we're going to be finished plenty of time. We'll probably have half the day tomorrow and all of Friday to work on Canada. So it worked out. All right, then give us some values of these three streets. You see them? And they want to know how many square feet are available. So this is basically just the same thing we just did. Right? Except for now they just put it on a street. Very tough.
62.4.
Got to start with a semi-perimeter. 62.4 plus 43.5 plus 34.1 all over 2 is 7,704. It's going to be like 68 or 69, 70. Is it 70 exactly?
Yeah.
Man, that's nice. I wish I could have done my mental math better if it was exactly 70. Right now to find the area, we're going to do the square root of. You're going to make me, do I have to write all this down?
No, I remember it.
Does everybody know what to do? Okay. I have to keep scrolling over. There's not enough space.
Yo Salty Dog.
Okay, we're back to the surveyor, trying to figure out the distance across the lake. So we're looking for side C. I would like to use the law of sines. What's required to use the law of sines? I need an angle and the side opposite. We don't have an angle and a side opposite, which means I can't use the law of sines, but I can use the law of cosines. Because I've got two sides and the angle between. Side angle side, I can use the law of cosines. So remember, if this is my angle, this has to be the isolated side. So using the formula, c squared equals a squared plus b squared minus 2 times a times b times cosine of gamma. And now we're trying to get C isolated. Is C currently isolated? No, it's being squared, so I have to take a square root of both sides.
Wait, how can we use that formula? There's not a right angle.
It's for any triangle. Our stuff is for oblique triangles, this whole unit,
Which means not.
not a right
I
triangle.
thought Pythagorean theorem.
It's not the Pythagorean theorem.
Wait, we used the word
A squared
oblique
plus
the
B
other day.
squared equals C squared is not Pythagorean?
That is the Pythagorean theorem. This has minus 2bc cosine
Oh,
at the end.
I was trying to get my paper. I don't even know
Oblique
where
we're
I need to pull that down so you guys can see the square root symbol.
Where are we at?
I drew it off the... We're on page 4.
We went backwards?
We absolutely did not.
We got a
We
new
were on
book.
page 6.
No,
We-
we got a new book.
Definitely weren't.
Where's the
We got a new.
Right here.
Are you not here yesterday?
No.
Huh.
That makes sense.
We got a new packet, yo.
That makes total sense. I was scrambling. Trying to find the page.
You were scrambling to get ready for the.
I was scrambling some eggs.
Get ready for the.
Anybody get the answer yet?
Four.
4?
No,
It's 978.514.
978.514. So we'll go with 978.5 yards.
4.1. I got a problem wrong because I didn't round to like 5 decimals, but it didn't tell me.
We
Yeah,
can
stinks.
formula on the test.
Yeah. If it doesn't take you go to the nearest tenth, I just put in every decimal you got. Just to, but that kind of stuff drives me crazy. As long as you've got it worked out, it'll be good.
I had it right.
Right. So I'm saying if that happens on the test, I will just count it. But if you if it happens on the canvas, if you let me know, I'll just give you credit on those.
Coach Coots.
Yeah.
Do we use this formula on the test?
You get to make your own formula sheet for this test.
Oh, that's actually. This is definitely going on there.
They said I looked at. All right, here's the next one. The Ford, yeah, that's a great time to get locked in when you got no responsibilities. Yeah. The 4 sequential sides of a quadrilateral have lengths of 3.3. So now I've got a quadrilateral. So I'm going to draw it. Here's A, 3.3. Here's B, 6.2. Here's C, 8.1. Here's D, 10.3. I think I did a good job. The other thing that matters here, because it says they are sequential sides, they must be in this order. It doesn't matter where you start, but I can't put 3.3 here and then 6.2 here. All right, it has to go in order because of the word sequential. All in yards. The angle between the two smallest sides is 95 degrees. So my two smallest sides are here, which means the angle between those has to be 95 degrees. Okay?
Oh, we're on the next one?
What's the area of this figure?
Gotta use Aaron's
Well, Heron's formula is for what?
triangles.
Triangles. Do I see a triangle?
No.
No.
This is John Harris.
We have.
But I can make 2 triangles.
Hey.
Right there.
1, 5.
So,
So what is this?
is there a way I can find the area of this one?
You could go 3.3 times 6.2 1/2.
A equals 1/2 times 3.3 times 6.2 times sine of the angle between them.
What?
This is from 4.1. I don't remember the names of anything.
Wait, so, does the.
This is called, Find the area of an oblique triangle. That's just all it says. It doesn't have a name. We did on page 5 of 4.1.
The area of an oblique triangle.
Yeah, area of an oblique triangle. Area equals 1/2 b times c times sine of alpha. Whenever you have side angle side, we can do that. So that will find the area of the purple section. Can I do that same thing with the other section that's not filled in? Well, I know two sides, but do I know the angle between them?
But it's just-
No. So how can I find the area of this piece? Any ideas? We do have that other area formula using the semi-perimeter.
Yeah.
To use the semi-perimeter, I would need to know all three sides. Do I know all three sides? No. Could I find the third side?
Yes.
How?
Well, we know that we can use that formula.
To find the area.
The formula we just learned about, because we have side angle side.
So we can do it with this triangle.
Yes.
We can do the law of cosines and find this side.
Yeah, yeah.
Then once I know this side, I can then find the semi-perimeter of the second triangle.
Right, so that's the law of cosine formula.
That is the law of cosines.
Oh.
So let's just go ahead, since we've got this formula written down, let's go ahead and find the area of the shaded region here. Has anybody typed this in yet?
Yeah, 7.
Oh my gosh.
6.9.
208.51.
Oh, I'm in
10.19.
We're all over the place.
I got 10.19.
Let me see what I get. I got 10.19.
Wait, no, I squared it. Yeah. I squared it.
You squared all of them?
I squared 3.3 and 6.2.
Okay, gotcha. Yeah, when I started looking at the numbers that are on the paper, I thought there's no way Jay's right. It ain't 200 something. I was trying to figure out, I don't know what happened.
I looked at this one.
I trusted you blindly when you first put it on there. I said, yeah, sounds good. That's better than the other answers I heard. There's like 4 or whatever it was saying.
It didn't look like it fit. The rest of the numbers.
Okay, everybody good with this? Now let's find the missing side length using the law of cosines. So I'm going to go c squared equals 3.3 squared plus 6.2 squared minus 2 times 3.3 times 6.2 times cosine of 95. And now then I have to take a square root. So I'm going to type in my calculator the square root of all of that garbage. 89?
No, 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 no.
I'm pretty sure the answer's right there. It's 7.27.
It's right where?
Yeah.
Is it written on there?
7.2.
7.2729.
What losers. Okay. So this is...
The right side of your phone. You wrote right over it.
So that's 7.3. So whenever we get a situation like this, well, I just round. It's just 2.
7.3.
Yeah, that sounds good to me.
Now we're gonna find the.
Now we need to find the area of the orange triangle. And I know all 3 sides.
Heron
So now I'm going Heron's formula.
square root.
Well, I need to know the semi-perimeter first. We did it yesterday.
Oh, yeah.
If you look back a page, like at page 2 or 3. S equals 8.1 plus 7.3 plus 10.3 over 2.
Huh?
12.85.
So this is 12.85. And now we're going to use this value for S with our 3 known sides to plug into the formula. So A equals the square root of S times S minus A times S minus B times S minus C.
Oh, dude, I ain't really that's what it's telling me is much more.
semi-perimeter. You add up all the sides and divide by 2. Like a semicircle is half a circle. Semi-perimeter, semi-perimeter is half the perimeter. 29.4. So the area of the purple triangle was 10.2. The area of the orange triangle was 29.4. So the area of the whole figure would be 10.2 plus 29.4, which would be 39.6.
Hey, that's what I got.
What did they write down? I don't know where I did it. They got 39.5. Again, if you get a tenth off like this and you don't want to redo the whole problem, just tell me and I'll count it. Like I'm not too caught up in all the tenths. Let's being very picky. It's all because you've probably rounded too early is the difference. Like where we rounded this to be 10.2 when it was really 10 point. And so then you would keep that. And then right here we rounded. We didn't round on this one. But we rounded when we found this side was 7.3. So we rounded so much that it makes you miss.
S again, S equals.
Oh, we're almost done.
So we're looking for the length of the wire again.
Oh, no. Whoa, no.
So I'm going to focus in.
37. We got to remember that one.
I'm going to focus in on this triangle. Right, I'm looking for the length of the guy wire, which is here. I'm going to call that X. I know this side is 66, and it tells me the height of the tower is 248 this time. Does anyone remember the shortcut?
It's something to do with 37.
It is something to do with 37.
You do,
It's 37.
They need to draw it all out again? You want to see all that garbage?
I wasn't here, so.
No, tell us the shortcut.
90 minus 37.
90 plus 37, which is 127 is that angle. That angle is always going to be 90 plus the angle of inclination right
Wait,
here.
wait, what? What angle?
I'm looking at this triangle.
That's the one that's right there.
This angle right here
Is 127.
is 90 plus 37.
The inclination.
The angle of inclination, or the incline angle,
Okay.
which was 37. I don't think they use that phrase. Maybe I should.
Pretty.
I think that's from my physics teacher.
And that's always.
Always. I can explain it. Just let's finish this problem, and then I'll show you why. It's a headache, and I'll probably screw it up. I don't want to do it right now.
We learned about this the day.
I did it with a problem like this before. That I did a terrible job. I did better in your class, but I did awful in 6th period. Twice.
127.
So I'm really kind of mad about it.
Choose cosine.
Wait, how did you do better in our class? If you had.
I did it with their class first, and then came back, had it ready for your class. Then when I went to try to reteach them, I screwed up again. It was just awful. So if I'm looking for this side, I know 2 sides and the angle between it. So I can do the law of cosines. X squared equals 66 squared plus 248 squared minus 2 times 248 times 66 times cosine of the angle, which is 127. Side is not isolated because it's x squared, so I would square root both sides. So x equals the square root of all of that, which they have worked out for us down here, is 292.5.
What?
Wait,
Offer.
I thought we were supposed to find the area.
No.
This one's much.
Well,
It does not say find the
no,
area.
I mean, I thought we were supposed to find the guy wire, but why did you do the area?
I did do the area.
Is that not locked?
It's not to find the area.
Oh, yeah,
It's
you're
to
right.
find the missing side.
Yeah.
So just.
I literally
Area
had-
is either Heron's formula or the 1/2 A times C times cosine of theta.
Does it matter which one it is?
292.5.
It is not. One of these has to be A, one has to be B, and it doesn't matter which is which.
Alright, guy wire is easy working nowadays.
Wait, so
It is on
With no
this
prior,
case.
with no prior knowledge, guy wire is harder than.
what is the guy wire?
Yeah, look out the window. You see the power line pole? You see the line that goes from the power line pole to the ground, you got the yellow, it's the guy.
I have one of those in my house.
There you go. Go ahead. You think you're special, 'cause you got a guy wire? You think you're the only one that's got a guy wire?
I have one.
Oh, there you go.
I got one.
You can't hear it, no wire.
I don't live in
That's good.